Hello and welcome to the video series on the Tour of Go exercise walkthroughs. Today's video covers the 9th exercise, images, from the Methods and Interfaces module inside of the Methods and Interfaces chapter. Rather than just showing you my solution directly, I will explain all the necessary Golang concepts and context for you to impart with a deep understanding of what each and every single line of code really means. In essence, we will be re-implementing a previous exercise in which we wrote a picture generator based on a 2D grid, where each pixel's blue scale value is calculated from its position. However, in this exercise, rather than creating a grid, we will implement the image interface from the standard library's image package on a custom struct. Namely, we'll be implementing 3 methods: color model to define the color.model for our picture, bounds to specify the width and height, and at to specify the color for each pixel. And the description gives us some hints as to how to implement each of these methods. Let us take a look at the provided starter code. A struct image without any fields is defined. This struct is then instantiated inside of the main function as a variable m, which is then passed as an argument to pic.showImage. The showImage function is defined inside of the pic package. Let's check what the docs tell us about this function. ShowImage displays the image m when executed on the Go playground. And the argument m is of type image.image, which is the exact interface that we just took a look at a moment ago. Our empty image struct does not yet implement any of these 3 methods. So when we run the code in the starting state, we receive a compile time error, which basically says that m does not conform to the image.image interface. All right, let's give the image struct the 3 methods to fulfill the interface contract of image.image. Okay, I've added the 3 methods with a blank implementation for us to fill in here on our image struct. Now let's click Format to automatically add the missing imports for image and image/color. Let's start by implementing color model. The exercise description suggests that we return color.rgba model, so we can just copy paste that here. All this says is that our picture is RGBA based. Now for bounds, the description also tells us what to return. Here this image.rect, so we say return, copy paste. We just need to define the width and height. So I'll create 2 local variables, w and h, 256 by 256. Those will be the dimensions of our picture. Finally, for the at method, we can also grab the return value from the description. So we'll return color.rgba, where v is essentially the blue scale value that will compute based on the position. So we can create v as a variable and set it to some function like x times y, as in the previous exercise. We just need to make sure that we wrap this in a uint8 type conversion, as RGBA expects uint8 values. Now let's run this, and there we go. We've solved the exercise successfully at this point. However, what if we wanted to draw multiple images, maybe with different colors and different dimensions? One approach would be to create a new struct for each image and then re-implement all of the 3 methods, but that can get repetitive after a while. The other approach, and the approach we're going to take, is to store the information on the struct itself and then use it inside of the methods. So we can add the width and height, width, height, int, and then we add them here in the declaration. Width is 256 and height is 256. Now we can also store the function to compute the pixel's color on the image. So let's add a function pixel, which is of type func, takes in 2 integers and returns a uint8. Now we set the field by declaring an anonymous function. Pixel is equal to func xy, type int, return a uint8, return, and then we can grab what we have been previously using as our function, and now call it inside of the add method with i.pixel pass in X and Y. Let's format, see if we made any mistakes. And there we go. Our little program is working just as before, but now we can easily create more images with maybe a different height, like 128, make it a bit shorter, and different shapes. So one cool function I found when testing this was x squared plus y squared. And there we go. Hopefully you've gotten something out of this walkthrough. Thank you so much for watching, and I'll see you in the next one. Peace.